Good afternoon. My name is Solvita ZARINA, and I am the moderator for the second panel, Sensory Perception and Sonic Immersions. And welcome to this panel, and let's begin. First, I would like to remind some organizational things. Each panelist has 20-minute time for the presentation, including 1 to 2 questions. And dear audience, please feel free to ask questions after each presentation. It is my kind request, as well as our conference lead, Rassa's request as well. And now I'm about to introduce our first speaker, Juan DUARTE. Juan DUARTE is a Mexican-born artist researcher based in Finland, working with environmental sound, exploring the entanglements between nature and technology. His research explores augmented listening of environments, combining artificial intelligence and remote sensing techniques. He holds a master's degree in new media from Aalto University, and he is a visiting researcher in the Institute of Advanced Media Arts and Sciences in Japan, a grantee of National Endowment of Arts in Mexico, and the Arts Promotion Center in Finland. Juan, the floor now is yours.
Hello, everyone. Thank you very much for the space, and I'm very glad to present my research in this conference. I will share my screen now. Hello, everyone. My name is Juan DUARTE, and as I changed briefly just want to mention that I changed briefly the name of my presentation to this one. And okay, so excuse me, there is a message that says that the breakout rooms will close in 50 seconds. Should I do something?
Yeah, that's the same as well. I saw the title.
Same as well. Let's hope that not. And it was at least someone from RIXC as a helper. I hope that we will not be excluded. If so, please return. We are now together to listen to Juan DUARTE. Please, Juan.
Okay, I will say this briefly if we can cut out. But originally, this doctoral research was titled Environmental Sensing Tools, but the focus has changed towards matters that involve arts, environmental sensing, and AI technology. The earlier phase included the production of two digital sound instrument artifacts and lectures and workshops on environmental sound.
So you are not yet in B? Oh, sorry.
They kick us out.
Sorry, Rassa, we were expelled.
Yeah, I will come back to the...
I
don't know. Oksana, Kā tu nevari ielikt?
Kur te ir visi cilvēki, kur ir jāieliek paneļos, kurus ir iespējams ielikt paneļos. Šie ir visi cilvēki.
So it leads to the production of instruments. It's the context of Aalto University in Finland, and I will present like some research background, the questions and the proposals and methods that I'm working with. So first of all, I would like to introduce the idea of deep listening, which was proposed by Paulino Oliveros in 2005. It captures an artistic method for increasing the aural and haptic perception towards space acoustics and non-musical sounds. Deep listening is supported for music improvisation according to site-specific conditions. Deep listening scope is valuable for expanding human sensory perception as it experiments with technologies to listen beyond human perception, including the range of micro and microphonic events, as well as electromagnetic planetary signals. Some of the methods that I'm interested to review in the deep listening notion of Pauline Oliveros is these ways of listening, where we can have these forms of attention and in humans to have like this focal attention and this global attention, but deep listening encourages to balance a way to listen in between these two forms. And in the case of this work that she refers from 1999 in Egypt, it comes these deep listening meditations, which is part of the corpus of deep listening. And I would like to share a fragment of this work. It says that from the field of sound that you are hearing, select a sound, focus on it and amplify it with your imagination. Continue to hold and amplify the sound. Even if the real sound has stopped when you are done, scan your body, mind, and notate your feelings. Imagine that your ears have extended range above and below the normal range of 16 Hz to 20 kHz. What could you be hearing? As you listen, the environment is enlivened. This is the listening effect. When we talk about multidimensional listening, we are giving attention to more than one flow of sound, in parallel or simultaneously, as well as discerning the direction and context. Readiness to listen is always present while already engaged in listening. And just to wrap up some other notions that I'm interested in this listening, the body is continually sensing and recording all of the information that is delivered to the auditory cortex. Even though we may not be conscious of this constant activity, this is why the brain-body knows far more than our mind can process immediately. From here, I would like to present the other part of my project that involves technology. And I'm working with remote sensing techniques, as I mentioned in the beginning. So in this case, the notion of environmental computing is related to this as a hybrid practice that measures our planet using sensor networks, which are often coordinated by artificial intelligence to analyze weather and climate transformations over long-term periods and large-scale geographies. My approach in this research combines deep listening methods with environmental computing techniques, and I try to reveal the possibilities to extend human sensory using instruments for augmented listening. It's interesting also to point out that the growth of today's AI must be questioned as it transports human biases from their foundation. In response to that, this research tries to tackle the challenge of using AI from a diversified view on nature and technologies, since human sensory is constrained by biological and cultural partiality. It is compelling to discover novel senses that perceive and attune to environments otherwise. Okay. From my practice designing musical instruments and sound instruments, I currently work on artificial deep listening to engage with the questions such as, what are the differences between sensing, measuring, and listening to the environment? How we perceive the surrounding by hearing or listening, what is the difference between them? And what does it mean for a computer to learn to deep listening? Is this actually possible? What kind of impact it would have in humans when computers are able to deep listen? And how does the history of sensing instrument contribute to devise deep listening instruments? In my earlier stage of my research, I reviewed that past sound practices have discerned the environment through various sound registers. Sensing the environment also employs coordination of human senses. In addition, technologies can augment our perception of nature. The aeolian harp is an ancient instrument in between artful instrumentation and the scientific undertaking. It gained notoriety as a sensing instrument by featuring a conversion of wind energy into music. Beyond the amusement produced by its resonance with the atmosphere, it was considered to forecast natural agencies and other non-human entities. Alike in the humanities, ambient poetics and ecomimesis brings a sense of the atmosphere. evoking the perceivable surrounding world. Reflecting on this idea, my project Aeolian Artifacts, it's reflecting on measuring devices as well, proposing an experience of augmented listening by computing wind's flux into digital sound. Moreover, considering the manifold transformations of the Industrial Revolution, the natural sonic environment changed with machine-related disturbances. Sounds-based work by futurists and Dadaists echo the industrial advent, celebrating the machine uproar over nature's quietness. In contrast, natural listening, such as the ones made by David Thoreau, highlighted the sublime nature at risk of decline by urban settlements. The Soundscape project by Murray Schafer in the 70s categorized sound sources as anthropophony, so human-made, biological or biophony, geophony, weather-related, and also recently was added technophony, technology-made. This results in an understanding of anthropophony as a source of noise and a threat to sounds from nature. Even though noise is valued differently, as in the media history of natural radio, described also by Douglas Kahn, it was discovered when listened to the Earth's electromagnetism in the very low frequency range of a spectrum. Those sounds inspired last century composers Alvin Lucier and Paulino Oliveros, as well as the research in this field. One of the main attributes of the anthropic radio is the suppression of unwanted noise by amplifying human signals above nature's noise floor. This gadgetry could amplify sound signals profiting from advances in cybernetic theory, for example, the vacuum tube. Sounds from nature became audible and perceivable through amplification technologies such as the phonoautograph, and present-day sound technologies are indebted to cybernetic epistemologies that recognize the complexity of noise. Consistently, the workshop Parasitic Radio that I developed covered the themes of natural radio and competing radioscapes. Just want to wrap up on this part. Reviewing this part of considering whether knowledge or exploring environmental sensing, I could try to combine these to amplify human perceptions of weather by combining it with contemporary art and environmental science. For instance, early weather-based artwork was advanced by the study of complexity in meteorology, such as Norbert Weiner's paper Nonlinear Prediction and Dynamics, which helped to develop current statistical forecasting methods. Recent media artwork uses sensors to translate diverse reactions and many other examples. This translation relies on signal transduction, which serves as a conversion of energy or information from one form into another. Environmental sensing systems involve an interplay between sensors and actuators for data acquisition. These systems can be used to become aware of the physical patterns in the Earth's environment, and artists working with environmental sensing employ transduction as a method to translate planetary scale experiences into human perception, as Douglas Kahn refers in Earth Sound, Earth Signal. Remote sensing is the systematic collection of sensor data from nature to produce digital information from Earth's patterns and changes, such as wind flux, cloud formations, and pollution. From this planetary perspective, one could think about a general ecology of natural technical continuum, where technology becomes a carrier of general environmentalization. Environmental computing is a term by Jennifer Gabris as a way in which sensor data is processed and analyzed. As well, is an arrangement between social and technical networks tied in studying nature through diverse initiatives, sensing animal migrations or predicting weather in climate science. Depending on the features of any given sensing phenomena, environmental sensing connotes specific modes of technology. This specificity is what Gilbert Simondon points out as intrinsic to tools and techniques, as they imply cultural relations and expressions. From this point of view, developing environmental sensing tools provides specific modes of technology and a call for experimentation on art and technology. Following the idea of cosmotechnics by Yu Hui, such specific modes of technology can develop other senses to preserve and renew our relations with other beings and the world itself. My ongoing artwork project I reflects on the environmental computing and the potential for developing cosmotechnics to create new senses through augmented listening instruments. I would like to just then go into the claims of my research, what I'm trying to formulate with previous background and questions. So I'm trying to think about that computers could learn to deep listen if we combine environmental sensing and AI. Sensing registers a complex experience, whereas measuring is a contingent and relative comparison. And listening is a cognitive process that involves both sensing and measuring and beyond. Computers could be trained to recognize sound recordings against sensor data. This way, artificial deep listening could create a novel sense for humans. For this purpose, sensing instruments are useful, as they augment nature's perception, combining art and science expertise. I would like just to finish my presentation by explaining some of the methods that I'm using in a general sense, and if I still have time, I think I'm good. I will just do it very quickly. I work with the philosophical and artistic method described by Paulino Oliveros, as I mentioned, understanding the human listening as a complex practice. It augments how we listen to environments. Also, I'm inspired by the weather-based sound artwork, which is relevant as it includes a perspective of indigenous histories that fuse the feminine, the spiritual, and the coming together of animal, water, and atmosphere prior to human existence, opposed to the Enlightenment's attempt to master nature. Theoretically, the project concept is rooted in the idea of cosmotechnics by Yuk Hui and open-air instrumentality by Jennifer Gabris. Also, the notions of cognitive non-conscious but Catherine Hale's computing contingency and its aesthetic implications by Beatriz Fazzi give a framework to my research. The capacity of computers to perform human agencies such as listening is relative to vital materiality and the agency of assemblages, including the vibrational practice of listening bodies. I'm interested to work with cybernetic approaches such as Cécile Malaspina and Gilbert Simondon, which are supportive to estimate nature's and technology's entanglement. In the, let's say, like the technical part or the more implementation side, I would like to say that the artificial deep listening is approached through novel machine learning techniques such as the semi-supervised learning and with generative adversarial networks, which is a technique used for image generation, but in this case, I'm using as a metaphor sound synthesis. And this is used to produce sound using a computer's promising cognitive capabilities, applies on sensor data and memory recordings over extended training periods. Since AI is both embodied and material, it only discerns with intensive trainings with large sets or predefined rules and rewards. This way, computers could be trained to deep listen by correlating sound recordings and sensor data to coordinate sound that is attuned to real-time environments. That's it. Thank you. And any questions, please?
Yeah, thank you very much. And every question is welcome, very welcome. Rafael Arar, please ask your question directly now.
Is it okay to use sound as well, or just typing questions?
Please use sound.
Okay, thank you for a great presentation. It was really interesting to get nervous, but I'm also curious about the deep listening in AI. What kind of methods are used to isolate sounds, as if you would isolate a specific sound with your, just your hearing and your imagination as well? But are there kind of filters or some kind of equalizing to kind of isolate a specific part of just tonal soundscape around the AI?
Thank you. Yeah, that's something I didn't really refer at all. But I found this research group in I don't remember right now which university, but it's the project is called Augmented Listening. But what they're doing is working with compression techniques and machine learning to to kind of create hearing aid devices. So that is pretty much like attuning human voice to be like a filter out from the environment and kind of separating these to kind of have a bit more sharp presence of human intention with technologies. But I think I'm interested to apply their methods of what they're using with machine learning, but opposed to that, or in a different way otherwise to attune more to environmental sound instead of human voice. So I guess in any case I have to train and record a lot of or work with existing environmental sounds or nature sounds to teach the machine what kind of categories are what, right? So I guess, yeah, that's more or less what I can say now. Thank you.
Very interesting. Wishing best of luck with
thank you.
Taming the AI, I guess, for this purpose.
Thank you.
Yes, thank you very much, Vigintas, for your question. Any more questions? We have room for one more question. If no questions, then thank you, Juan, very much. And I do apologize. We did kind of a, how to say, design mistake. We all did this. We were assigned to panel A, but this name was assigned for panel B, this sensory perceptions. We all read sensory perception and sonic immersions, and all participants arrived in panel A room. Therefore, we were expelled, and so on, and so on, and so on. Yeah, well, it is a kind of a, how people appreciate and how deep they read texts. Yeah.
Thank you very much.
Yeah, and now please welcome our next speaker, Moon, also known as Martina ZELENIKA. Martina graduated from the printmaking department at the Academy of Fine Arts of the University Zagreb and the Academy of Visual Art and Design of Ljubljana University. She has more than 17 solo exhibitions and has participated in new media festivals as well as international exhibitions in Austria, South Korea, Germany, Denmark, Belgium, Slovenia, Latvia, among other countries. The artist is a member of the Archive of Digital Art and Network for Women of Berlin's art scene. Martina, the floor now is yours.
Thank you. But the breakout room will be closed in 50 seconds. Please help.
Yeah. No, then let's return. Let's return to our breakout room. Never change, because no, what's to do? Yes, but let's speak. No, maybe something good will happen.
Okay, I can share my presentation. Can you hear me?
Yes, perfectly. Oh,
great.
One more thing to do is floating windows, something to do with the
database, because we didn't want to make it hierarchical. And the next step, sorry, should I change my?
Okay, Martina, did you manage these floating windows of Zoom? Because when you show your presentation, everything is nice except these nearly black shapes. But now you are not sharing your presentation, please.
Can you see my presentation or not?
Not now.
Not now?
Yeah.
Maybe the connection is not so well. Share it again.
Yeah, now everything is perfect. Yeah.
Stop share, just a second, one more time. Sound optimized clip.
Very nice.
Are we in?
Yes, we are in, but together with black shapes. Yeah, at least better. Better.
Yeah, all right.
Yes. Let's concentrate on sound.
Oh gosh, all right. So, greetings everyone. My name is Martina ZELENIKA, independent interdisciplinary artist based in Zagreb, Croatia. Well, I don't specialize in the field of sound art, but I like to use interdisciplinary methods to explore unfamiliar places in order to find familiar senses. Excuse me. So let's see this brief introduction. Introduction to the history, then idea of the human body as musical instrument. I'm focused on biosensors, then meditative drawing technique, a meta-signal sonar system, which I developed 2017. And my project Receptilium, which is interactive immersive performance, also involves biosensors. So briefly, introduction. People have been playing with the boundaries between visual art and music for a long time. It's a more than 100 years old game. As with music, colors, lines, image composition can be keyboards and act directly on emotions. So we all knew and we are familiar with the term synesthesia, or it's also a fusion of the senses. So the color can be a keyboard as line as well. At the same time, theremin music was an invention. The theremin is electronic musical instrument controlled without physical contact by the thereminist. So let's hear just shortly. Can you hear it? All right. Can you hear the sound?
Yes, we can hear very
Okay.
well.
Sorry?
Everything is fine.
All right, great. Then sound can be derived from almost everything that surrounds us, with which we interact, and directly from our body. So biosignals. Today, we can witness the existence of technological configurations that allow the body to be considered a musical instrument. The sound is a part of communication system. It's a language and speech. And as is already said, that I'm going to focus on biosignals or biosensors. So we have two types of technological sensors: external sensors that report the result of body gesticulation, and biosensors are electrodes placed directly on the body that report physical activity. And this is one great example.
To produce a higher note, the muscles are tensed. In its current form, the biomuse translates the electrical signals into violin and bell-like tones. Closing the eyes and relaxing creates alpha brainwaves, which produce the bell-like tones.
Noise type sounds, and what the biomuse does is it looks for particular sound information within that noise that it can use to control the synthesizer. I mean, the key to the biomuse is trying to be able to be controllable.
Yes, and for example, the recent work of well-known Atao Tanaka is a myogram, where he used EMG myo interface, which is commercial interface. That's a very good one. So he's a performer who is taking research out of the lab onto the stage and use signals, biosignals for decades. Let's make it faster. So he's using this myo interface 100%, and manually he's making wrist rotation, hand flicking, finger movement, etc. So another project of his is suspensions. It's made in collaboration with Sarah Nichols. She's a pianist. And it's also a great example how musician can play sensors while playing musical instrument. Okay, so another example is Corpus Nil by Marco Danurama. He involves artificial intelligence, but he doesn't use biosensors. Okay, let's do it. Another chapter. Here, I would like to present my work. So the idea of the human body as a musical instrument came from drawing, a classical handmade drawing. Drawing is the basis of my artistic creation, and it's also the primary human expression right after the sound, the voice. So in 2017, I started developing an artistic research cycle called Meta-Signal Sonar System that reflects my need to search for a universal language. It is my search for the perfect language. So these are, for example, life-size drawings that we see over here. So I use a meditative approach and semantic approach to create visual compositions. I call it emotionally positive attractors and poetically called sound galaxies. I have to say that the main medium in this drawing process is my energy field and emotions or vibrations, which is considered language without limitations, consciously denying the limits of our language that naturally represents the boundaries of our knowledge. So before each act of drawing, I meditate to achieve calmness of emotions, mind, and body. And here is the one example. In this video that I'm going to present you, I demonstrate a meditative drawing technique, MES, which is a Meta-Signal Sonar System. So in my work, there is a range from a simple point attractor to variation of a complex or strange attractors from a mathematical point of view. But at the same time, is based on Jung's theory of chaos related to emotional attractors. So as a previous colleague mentioned, Pauline Oliveros and deep listening, here is the example how I use deep listening to achieve meditative state. And this is the result. I have to say vibrations matter doesn't exist anymore, but drawing techniques does. The video is a kind of visual meditation to you, for you viewers. So please relax now and enjoy. All right, so this was the huge and important part of the Receptilium project. So now is the time to present you Receptilium, which is an interactive immersive performance act where the human body plays the role of a musical instrument connected to EMG and EEG digital extensions. So Receptilium includes the act of creating a visual artwork and sound transformed from biosensors. Biosensors collect raw data in real time and then generates a direct sonification and visualization process using a software Max MSP Jitter. So let's take a look. Okay, so the Receptilium has been only performed once. It's the first demo performance at the Sound Embodied Festival Zagreb. Hopefully I will do it again. I don't know where, but it should be somewhere else, maybe next year. Let's see, configuration 1. It's for the Muse EEG, so which includes 4 points alpha, beta, gamma, theta. My technology and lead development, Ivan Vitsen, he made all this possible. So also everything is done or made in Max MSP over here. And configuration 2 shows the whole setup. I mean, gesture sensors and brainwaves sensors. So we have 3 different modes, so like levels. And yeah, so with the free, I'm free to swap wires. So wires are here to change something else. Mapping is also useful. I can range a frequency to high, from high to low, or vice versa. Combinations of playing instrument and sound effects can be obtained and saved as such. So this is like a really like a let's say a little bit massive configuration, because over here we have 1, 2, 3, 4. So it's follows the brainwaves points. Then additional details. Yeah, as I said, I switched the mode. As I said, we have 3 modes. With left hand by double tap twice, and the right hand with which I draw, which is in constant motion, drawing elliptical lines. The sound follows of head movements. These are 4 recordings from this performance made 2018. So let's take a look. So one version, then another. So probably you can notice the differences. So from my brainwaves, sound gives fluid harmonic music. It's a symbiosis of chamber and digital ambient music. While I draw, there is a different sound, like Here you can hear this sound as well, like elliptical sound. So, distinctive feature of receptilium is that it transforms and generates one media into another, then into third and fourth media, which involve the experience of the observer, deep listening. And in the end, the purpose of this act is to invite the audience to meditate together, to tap into the energy of the cosmos, because God created an ordered universe out of the chaos. So we are basically in one kind of attractor. Only then we can. Only then can we unite. We can unite and rise above the challenges confronting humanity today. So listening is a mysterious process that is not clear to everyone. And at the end, I want to. I would like to take this opportunity to invite you to cooperate for the further development on this project, or maybe you have some kind of institution for presenting this performance. So please find my contact over here, and I'm very eager to hear from you. Thank you.
Thank you very much, Martina. And since we had this problem with breakout rooms, we are allowed not to hurry up. We are allowed to do things in a very calm pace. I'm waiting for questions, especially when you speak. I would be very happy to hear something for all other sound specialists.
Yes, please.
If it's okay, I'd like to ask a question. So thank you for the presentation and for showing the inner workings of your performance. But I have a question which makes me very curious. Like in the examples that you showed in Otto's works, it's very distinct that it's just electronic signals and it's very direct going into the speakers, the signals from the EEG waves. And in your performances, it's adhering to Western music harmony and traditions very strongly, because when you're using max, MSP, and jitter, well, it's obvious that it's not the direct signal, but you get numbers and then you link them to anything you want. So the end result, the music is affected by the initial signal, but it's not designed by it. It's designed by someone who made the patch, and it's very specific choices of sounds, of intervals, of what frequencies are possible, and what motion will create what sound. So the sound is very detached from the motion. It's very pre-designed. So why is there a need to adhere to Western music harmony and to kind of make it beautiful in a sense? And how do you choose the sounds then? What parameters do you use to select what sounds you're going to use and what you want it to produce as a result?
Thank you for a question. Well, it was intuitively how I visualize the whole concept, and the sound that I wanted to make, it is my attention to make something beautiful, not disturbing, but also there is some parts which are annoying and disturbing and maybe sounds pretty raw. But the whole intention was to make environment for the people and make it available for meditation, for some kind of invitation for visualization. Yeah. I'm not a sound specialized specialist, so I don't know how can I describe more. Basically, I use my intention to make good environment. That's it.
Okay, thank you. But then another like conceptual question arises then if you kind of pre-design the sounds and how it will sound, and what's then the conceptual difference, I guess, between just playing the sounds as it's kind of produced, you know, or having them, the sounds kind of start playing without the performance of drawing. I'm just curious what that adds to the performance, or how it elaborates it, in your opinion.
I mean, it elaborates with my movement of the body, but it's also the state that I'm achieving during the performance. So the process of creation is involved. So all these beta, theta brainwaves correspond to this practice of live drawing, and probably without drawing will be different, but there is many other possibilities how to select and involve different features and maybe different types of recording these sensors, physical motion.
Okay, thank you.
Okay,
Wishing
you.
The best for getting some venues to perform it again.
Yes, I need the better environment conditions to perform this project. So it will be great to have different conditions in future. Yeah. Thank you.
Thank you so much, Martina.
Welcome.
And now please welcome our next speakers, Gabriela Mungia and Guadalupe Chavez. Very sorry for pronunciation. Two transmedia artists. They investigate possible rhizospheric interspecies communication through the indiscipline of electronic arts, bioart, environmental humanities, cultural biology, and southern epistemologies. They coordinate a rhizospheric laboratory, an experimental education project focused on ecology of soils, art, and open technologies. Their artwork has been presented in different international festivals and has received several international and national awards. And now, you both are very welcome. I'm not so brave to pronounce again your names. Gabriela and Guadalupe, please.
Hello, it's perfect, Solvita. Thanks for your introduction. We are going to share our screen just a second. Okay, I think everybody is seeing okay our presentation. Okay.
Yes.
Yeah.
Well, hello everybody. I'm Gabriela, and my colleague is Guadalupe, and we are Electrobiota Collective. And today we want to share with you some reflections about our artistic practice. Our multi-species collective embraces the rhizospheric territories as a starting point for experimentation, creation, and technological artistic research. The rhizosphere is a thin layer of soil where plants, their roots, fungi, mycelium, Different species, including microorganisms and an infinity of geochemical agents, are always in motion and in constant processes of exchange that, according to their stability, can help or harm the sustainability or also the fertility of soils. This physical, but also material, political, and poetical space has become our tool and territory of action to reflect and imagine other possible biological and terrestrial vitalities, materialities, and agencies. We also think that the discipline between art, science, and technology, nurtured by radical imagination and speculative thinking, is a very necessary place to reconstruct new knowledge, to rewrite our relationship with nature and the world. In this sense, it is very important for us to think about what technology is and what it should be used for. Therefore, in our practice, we are interested in questioning the technocratic and hegemonic principles with which we relate to nature. For this, we strongly embrace the fields of environmental humanities, soil ecology, and Southern and Latin American epistemologies of del buen vivir, of the good living. We ask ourselves how the role of arts, science, but also of ethics allied to ecology are necessary tools to build critical spaces to debate, to friction, and also to disarm our contemporary technological imaginaries and realities. And these reflections have become a very important starting point for in our work, how we can also learn to recognize and rescue nature's own technologies, those subaltern and border technologies that allow us to reveal other kinds of thinking and feelings toward the world. Technologies that can also help us to change our political affective perception towards other companion species and also to planetary natural phenomena and matter. As Donna Haraway says, it matters what ideas we use to think with other ideas. It matters what stories make worlds, what worlds make stories. From this, we have developed different open source sensing sound devices. We think of them as sensitive interfaces that embrace not only technical aspects, but also ancestral and communitary knowledge that can help us to hack traditional techno-scientific practices. In this sense, our practice are always situated exercises, contextualized to very specific urban and natural territorial problems. From these approaches, we create a space for artistic creation and research open to the community called Laboratorio Risosférico. And my colleague is going to share with you more about the development of this project laboratory.
Good afternoon. It's a pleasure to be part of this festival with such interesting artists and researchers. I'm going to share with you about the Risospheric Laboratory. This project was born in 2016 and is the root of our technological artistic practices in which we are interested in observing and learning from different natural processes of multiple companion species that inhabit the rhizosphere and whom we share every day. This laboratory was born from questions such as what are these other intelligences and sensitives that we as humans must learn from, and it is possible from this to tell other stories together. The Risospheric Laboratory, or Laboratorio Risosférico, focuses its research on interspecies dialogues through collective and collaborative creation. For us, interspecies dialogues are exercises to trace links and to approach to what is meant to be interconnected and interdependent to the soil, revealing other possible views and listenings, expanding our human perception from the encounter and communication with more than human ecologies, allow us to decentralize language and process of knowledge construction. And hopefully we can move away from human exceptionality. And so we believe that these dialogues are interspecific intimacies and that arise from sharing with soils and looking carefully at the otherness and aliveness of these dark alterities. Sorry. And Maria Bugdala-Belevska explores how altering the imaginaries of soils as inert matter subject to human can transform contemporary human soil affections. In this way, these affective emotional exercise are something more innocent than others. And they are powerful experience to enhance other ethics of care. For example, perceive the sense of petrichor when we smell a touch wet air, or when we patiently wait for a seed to germinate. Also when we are attentive to the circadian cycle of plants, or even when we discover a new population of earthworms in our gardens, and we observe their ways of creating society through the exchange of physical, geochemical, and environmental information and matter. And these new involvements with soil aliveness open up a sense of earthy connectedness that animates and reaffects material worlds, and a sense of more than human community in those involved. And this way, this notion of the species becomes a diffuse category as we try to construct new narratives of cohabitation, coevolution, and sociability. And we like to embrace in our research the biological and cultural concept of symbiosis and doing being with others or the Mr. After these reflections, we would like to share with you two projects in which we intertwine our research of interspecies dialogues in the resource sphere through some exploration and the development of open software and hardware technologies. For example, in 2016, we have the opportunity to participate and be winners of the Untitled Electronic Artistic Award in Argentina. And in this contest, we began an exploration about the possibility of hacking human communication network to extend them to other possible interspecies communication. In this sense, our work takes a poetic dimension in which sound becomes a metaphor of interconnection and communication of those voices that lie underground. This is how Resourcefera FM project came about. This site-specific sound installations was initially inspired by the melancholy feeling experienced by the species that inhabit the resourcefera territories in urban space. For example, plants and their roots. We know that they are systemic beings that, despite their subtle movements to our eyes, show us day by day their intelligence, their ability to express themselves and terraform the world, and especially their vitalities and resilience. However, in urban environment, this rhizomatic plant network of communication with other species through different geochemical and electrical exchange is segmented and fractured between large plates of concrete and pollution. Some of these projects has led us to explore the transformative potential of art when it is strongly linked to the territories. In this case, a series of site-specific activation accompanying this process of co-creation with human and not human networks and systems. During the exploration process, we developed a low-scope biotransmitter which can sense different bio and geoelectrical impulses from soil, and through an amplifier is transforming this signal into audible oscillation, and that could be transmitted via radio frequency and remotely tuned through analog radio via FM frequency. This project interconnects biological and technical elements with soil sonorities to give shapes to complex organic living radiophonic systems fed by organic and geochemical process and transforming of the resource. and transformation of the resource.
Well, and finally, we would like to share with you about our latest project, Terrafonías. This project was born from an initial question: how speculative thinking and environmental humanities can be tools to approach possible alternative ecologies through ethical and effective practice in the intimacy of terrestrial process and their environmental problems. In this project, we focus on the study of the carbon cycles that circulate through the atmosphere, the oceans, the soils, through different chemical, physical, geological, and biological processes. This work takes the form of a site-specific exercise and a mechanoacoustic instrument where we imagine the rhizosphere as an exchange membrane between the soils and the skies. In other words, this installation explores how plant communities and rhizospheric territories fulfill important environmental processes for climatic balance, such as absorption of environmental CO2, the fixation of nutrients and carbon into soils, and the release of oxygen to the atmosphere, for example. In this project, we propose 4 lines of work: biosensing and feedback, sonification, data-assisted sound composition, and digital fabrication, that we are just going to talk about 2 of them, more focused on sound. And well, the biosensing technique in the field of bioelectronics focus on the measurement of physiological activities or the detection of organisms. However, it also encompasses the use of devices incorporating the activity of various biological agents to detect presence of particular chemicals. For this work, we developed a complex sonorous biosensing interface to analyze and compare the measurements of environmental atmospheric carbon dioxide versus the generation of oxygen through plant photosynthetic processes. Through the capture of chemical environmental data, we developed an analytical study device, a hardware and a software, like this machine you're seeing, that collect and analyze the information, searching for unique and specific and very dynamic measurements, allowing us to study this process sonorously. What we found interesting about this biosensing process beyond the technological development was also to think what to do with this information, what these readings were telling us, and what process we could speculate with this data, right? So we found that the biosensing process allows us to analyze and recognize patterns over time. However, we also found that it is a limited process, since organic and living temporalities are very, very different from human temporalities. And in terms of microscales, the exercise of linear translation and traduction of information to sound did not allow us to really delve into specific and relevant moments in the different process of measuring. In this installation, we are measuring CO2 and oxygen gases, soil capacitance, ambient temperature and humidity, and the amount of volatile organic microparticles in air. Therefore, it was important for us to that the sound composition of the piece was not exactly a direct data translation exercise. We paid a lot of attention to analyze the information we were receiving. We were very interested in being able to focus on the slight variations and zoom in and zoom out on those minimal but important processes in a dynamical way, allowing us to feed or to nourish the sound composition from these minimal variations. So we started working together with Germán Pérez. He's a developer and programmer, And together we create a platform and a software that allow us to generate a data-assisted sound composition process that was driven by the statistical, comparative, and temporal analysis of the information we were collecting. In this sense, the temporal process in the comparative analysis and the real temporality of the organic and chemical process were the ones that generate the narrative of the sound composition. The more time we measure, the richer the analysis process we have. So we believe that this was an exercise to create a kind of network of sound influences nurtured by the gestures that the biosensing interfaces offer us, together with other gestures that were generated from the dynamic analysis of data, together with randomic and generative process that were modifying the melodies and the rhythms of the performance. We played somehow to lose control, allowing the interface to gain more influence and generate its own sound behavior from the intimacy with the environmental phenomena. So hope you like this project, and if you have some questions, we are open to listen. Thank you.
Thank you so much. Collective Electrobiota, Electrobiota. And thank you for amazing videos from my side. But I'm very keen to have your questions for both Gabriela and Guadalupe. There should be questions. You are all sound artists, and even I have some remarks, but as a moderator, I would like first to invite your questions. Vigintas, maybe you have a question, or maybe another one. Eva, maybe you have a question. No.
Honestly, I'm very fascinated, but I can't formulate something specific enough to make it into a question.
Yeah, thank you, at least for the comment. I have a question not connected with a specific topic, but I am wondering where was the place for your last project? In Mexico, in other part of the world?
It was kind of difficult first because we were like in the middle of a pandemic and everything was closed, and we were in that right moment in Argentina. So we have the chance to go to a small, like a forest open. It's a protected area really close from from the city of Buenos Aires, and we decide to work there. We start to make like exploration a little bit about what kind of plants, what kind of species were there, and we decide to make this site-specific intervention that it took us like few days to prepare everything, and took this huge installation, make it work in the outside because we don't have where to plug to electricity. So we always think this kind of problems when we work outside on and well, it was like quite challenging, but we're very glad, even though we didn't have the chance to make this piece like in other place, more open to people that can interact with others. It was like just both of us working in this art piece, and the birds and the plants, and nobody has the chance to hear or be part also to interact with the installation. but hopefully we hope we have another chance. Somehow it's like a work in progress.
Yeah, thank you so much. And maybe after this short explanation, any more questions? Really not.
We have see something. There's something in the chat that says, "Can you speak a bit more about this, about the voices of the soils?" Yes, thanks. It's a great question. When we start working together as Electrobiota, the first thing we decide to work was like, okay, we want to work with plants, we want to know how they express their community, try to communicate with them. And the first thing that we have been working like since 2014 together. So one of the first experiments is that I think everybody has like the same processes. What kind of thing or what technology can I just plug to the plant and get this kind of information? And I think that both of us think that this is sometimes like a very anthropocentric way of relation, like trying to extract, trying to be like a Frankenstein plant and electrify it. And in somehow as a process, we start to work more from a speculative way of how the environment itself, like don't try to not understand plants just as a species and try them to understand them as a resource sphere, as a whole, where soil, where minerals, where water, where microorganisms, where roots, and all this living organic rhizomatic network is always communicating. So we start to focus more at the rhizosphere, like trying to take out this other kind of information, like the color, the smell, and being. It's also like Martina says, as before, we are not musicians. We do not come from a musical or sound background, but both of us have been working of how to amplify that very small sounds, very small gestures on the grounds that we think that can express so many things. So that's why we start to focus not exactly in this idea of how to extract things from plants, and more to understand this, the gases, the chemical reactions, the different phenomena, how to understand that if a leaf is more green, or the sky, or the light, to understand like this membrane, the rhizosphere as a membrane between soils and environment. So we always says this, like the sounds underground, that it's more like a chemical biophysical process that we try to focus more.
Yeah, thank you very much, and thank you for question in chat. And now I'm trying to reach, everything is now done with questions. And thank you very much. I think your presentation was visually very appealing, as it was with previous ones. And now I'm excited to introduce our last speaker, Vigintas Orlovas. Vigintas is an artist and researcher working in both the visual and audible art, and focusing on the relations and connections of these two fields. Vigintas is taking part in art exhibitions since 2009, in conferences since 2014, and he started teaching at Vilnius Academy of Arts, Lithuania, in 2015. And he has earned his doctoral degree in arts in 2019. And to add, he's really very active for questions, and I'm excited to have your presentation now. Vigintas, the floor now is yours.
Thank you so much, Solvita, for the introduction, and everyone for being here, for the committee as well for accepting my my paper. And it's just wonderful to be here in such a community of artists with interesting presentations. And today I'd like to present some of my own experiments that are actually not as finished works as some of the other parts that we've seen today, but more of a attempt to develop methods for researching sound through visual means, through Schlier and flow technology. And I will not actually be sharing my screen, but I'll try to present it in the same screen that my camera is at. So hopefully you can see it, and perhaps you can just spin it to your screen to enlarge it. So can you see the presentation already behind me?
We can, and with right mouse click, we can pin in order to see this in enlarged environment, and I did it. It looks perfect.
Okay, great.
I hope for other participants too.
So first of all, I guess some background is quite necessary. So during my doctoral studies, I've been researching the relations of sound and image, and the various strategies other artists and researchers have already tried to use to connect these two fields. And I've been analyzing a thing I coined sound image, and just the part in between these two fields. So in that sense, the field could look like this. So if we have sound image in the middle, we have two core parts of it, sound and image, and also the perception as our human bodily limitations. And quite a lot of activity and lots of research has already gone into this field, starting from the research of cymatics, from musical painting, and so on. But Schlier and flow technology so far hasn't been applied that much in arts. And it deeply relates to the methods of optics to put emphasis on things that are not visible to the naked eye, and also to acoustics, because it's a direct development of wave properties of sound. So if we were to go a bit more into this, I could try talking about what's already done in this field. So first of all, we must talk about the part that it was first observed by Robert Hooke in 1665 as a phenomena, but in a way, different way, but just Robert Hooke already perceived that differences in pressure in gases produce some inconsistencies that could be visualized through the work of an optics setup of mirrors, and in Robert Hooke's example by candles. But later it was further developed by Jean-Bernard Lonfoucault, whose name I'm sorry if I butchered, but I just don't know French well enough, and combined into a system of using two concave mirrors. So it's also applied quite a lot in aerodynamics research, and this is a Schlier photograph, which is from NASA's archive, and here you can see the sonic boom, the sound wave just propagating through air. So by seeing this and being actually quite fascinated by space research and seeing that this method visualizes and just helps us see the differences in and inconsistencies in pressure in gases, I realized that it can also be applied to sound, probably because it's also an inconsistency in sound, not in sound, in pressure. But in terms of what's already done, we can also talk about cymatics, because it's directly related, and cymatics, the study of wave phenomenon, research by Ernst Chladni and quite a lot of earlier researchers, but I guess the most important work was done, sorry, most important work was done by Hans Jenny in his study of wave phenomena, cymatics, because he developed a huge archive of visual information, like we see here on the left, of just how sound moves and how it affects matter, both as liquids and powder material. And this huge archive has inspired so many artists to use cymatics in their artworks and their installations. And I myself have applied this method. And I'd like to show a quick example. So this is first of all from my personal archive, the same wave shape, just bass frequencies, and we can see it analyzed as spectrum, as frequencies, but also in the middle part and on the middle on the left, it's affecting water that's filled into a speaker. So how does that look visually? I'd like to show a quick example. So I don't know if the low sound was audible, but it was part of an installation with microphones in the setup that it would react to the sounds of the spectators, but also there was a low sound in the exhibition space, and you could see the pattern on the water. So this method is, just by seeing Hans Jenny's works, is so visually inviting to many artists, and it's also very simple because it doesn't require lots of materials to set up. And that was kind of the premise I had, that if shear and flow works in a similar way just with gases, perhaps creating a visual archive and analyzing if it works, first of all, could be a wonderful tool to inspire others to use the same method. So what I did was, first of all, I tried to figure out if it works. And this is the basic setup I did in my studio, just to test if the method works and just to try and develop a basic setup. So what you see here is a concave mirror setup and a light source, a pinhole. So what happens is you shine a light from the pinhole and it goes kind of diagonally, spreads out evenly like a cone into the concave mirror. But that mirror captures the light and makes the photons kind of travel in parallel lines towards the next mirror. Which, again, being concave, concentrates it back to a point. And if you place a camera, let's say here, or a screen in the focal point, you might see some differences in pressure in between the two mirrors. So by placing a speaker in between the two mirrors, you create differences in pressure. But however, this setup was very not precise. So I also added a candle to create some very steep differences in pressure by creating heat, and just affected that with sound. And I was able to see in the screen that there is some movement, but due to the low quality, I couldn't create any proper pictures. But having this in mind, I just looked up which companies produce high quality mirrors and wrote a couple of letters to see if someone could collaborate on the research. And the company that actually did reply first was Opto Sigma, or also known as Sigma Koki, from Japan. And they were generous enough to invite me over to their garage lab to do research there. So the next step I did was that since I wanted to create an archive of sounds and visual information, I developed something that I could easily take with me to my internship to Japan, some kind of sound generating elements. So instead of using synthesizers for wave shapes, I just used pure data and constructed a synthesizer of basic waveforms like square, triangle, sine wave, and sawtooth that are most commonly used in sound synthesis. And this part, I guess I want to talk about how I further developed the system is by going to Sigma Koki. So these were the first experiments by just using a proper shear and flow analysis setup with high quality mirrors and light source. This was just testing if it works. So what you see on the left is the thing that you have for cleaning electronics, just pressurized CO2. And placing that in between the two mirrors, we get this result, quite a stark difference in pressure, because it's a different gas that refracts light in a different way. And here on the right, it was just a small vial with alcohol that would vaporize and would produce this, just also differences in the gas. So these were just test methods to see if it works. And sadly enough, even with a quite sensitive system, having a speaker in between the two mirrors was not enough to see it in high details, just vaguely. So I had to come up with something else. So this is how it looked like. So that's the alcohol kind of vial with the vapor. And this is a speaker attached. And so we tried to concentrate the sound just to see if that helps to kind of concentrate it into a funnel. And it did increase the quite how much sound affected the matter there and the gases, but it was still not consistent enough because the vapor would be very very dynamic on its own, even without applying sound. So it wasn't something that could be used to research something methodically. So the next step was still using a funnel to concentrate the sound, but also adding CO2 to the funnel to have different gases and different refraction rates. And that produced quite, so that's the full setup, but that produced quite visual results. And here you can see both different frequencies and different wave shapes in this setup. So you can see the end of the funnel that you just saw here. And without affecting it with sound, it would just be a straight line, just like we saw in the early examples. And also this is like the full setup that I used in the Garage Lab. So here you can see the light source, the pinhole, a mirror, another mirror here to capture it, and a camera over here. And in between we have the sound and also it affecting the CO2. And that's basically just a synthesizer of a laptop with a MIDI controller and some 100 yen shop appliances to create the cone and stuff like that, because it was under a limited time and I just had to use whatever I had around. But how does this look like? So knowing that this already worked, we tried to also, with the help of a team at Sigma Koki, try to kind of minimize the system to turn it also as an idea into a setup that could be easily portable and rather cheap to produce. So it could perhaps be used to, as an example, in just physics experiments and basic introductions to the phenomenon. So this is the final version of the setup, kind of small, almost like A4 size. And what it has inside it is again, just a small light source rather than what we had in the original one, because this is an interesting development that we've noticed throughout the research, that actually the less light, the more sensitive it gets, because you have less photons and it's easier to, refract them with the sound. So actually the less light you have, the more sensitivity in the setup you have. So it was just a very weak light source going through a pinhole in the latest version and having kind of the same setup. So yes, the pinhole, then the mirror sets, the holders, and a small speaker connected to a cone that had a constant flow of CO2 gas into it. So, and projecting it on a screen of paper and just filming it with a camera over here. So as a result of what that might look like, these are pictures on the paper screen. And you can see different frequencies like 480 hertz and 1440 hertz. And also, it, as expected, produced the same qualities as cymatics, but higher frequencies would produce more complex, smaller structures, where lower frequencies would produce more visible, more pronounced wave shapes. And I want to show you some segments from the archive again, so you can see how it actually looks and sounds together. And so you can see the different wave shape, even if it's the same frequency, does affect the flow quite a lot. And let's see if we jump to higher frequencies. Also, an interesting part that we've noticed through research was that you actually need lower amplitudes for lower frequencies, whereas for higher frequencies to affect it in the same amount, you need a lot more amplitude. But this was kind of enough for my basic premise to figure out that it does work in this way, and that it could be used for sound analysis. But naturally what followed, as I'm an artist myself and I do use sound as a medium, I wanted to try and create something for the system, something that would look and feel at the same time combined, but not necessarily just pure frequencies, but something rhythmic perhaps, just seeing what could work for example, music performances while using this setup. So this is a short excerpt of trying something different rather than just basic wave shapes. Something rhythmical as well. So in that sense, it's a successful experiment, but it still needs some further development. So I guess I could try moving to the conclusions, because I'm seeing that I'm running low on time. So to conclude, the flow of sound can be seen by using the system, and again, that's what I already mentioned about the lower and higher frequencies. And the flow is deeply affected by physical parameters, such as how we place the nozzle, what gases we use, the temperature, and it does need an isolated environment to work most precisely. And it also does work with without different gases, but to do that, to see sound in better detail and to have the shapes defined more precisely, we would need a more sensitive system with bigger mirrors, less light, and more sensitive camera and lens. So that's something for future research, but now it says that it's work. And perhaps a model could be developed to use it as exploration of phenomenon around us. Just a small case, for example, to show in schools or some other situations. But what I think is most important, that in my opinion, seeing the sound itself and the phenomenon, not something just visualized on data, something that's evolving around us all the time when we're speaking, and we don't see it with our human senses, but these changes, these things are happening all the time. And I think just experiencing is something of an embodied experience, something that is not necessarily easy to describe by words, but I do hope that developing this archive further and analyzing the phenomenon further could perhaps serve the same cause as Hans Jenny's cymatics, in a sense of inspiring others to try and explore it and apply it in arts and for sound analysis or for aesthetic purposes. So I guess that could conclude my presentation, and perhaps someone has some questions.
Yeah, thank you very much, Vigintas, and we now saw another technology, how to present. Was it Prezi, or was it some of these programs for prototyping, or something another?
It was actually a piece of software called FreePlane, which is a development of FreeMind. It's a mind mapping software. And I love it for both presenting and mind mapping projects as well. It's because it allows some, I guess, fluidity and interpretation of what to do, and not necessarily stick to just papers and pages that are already preset. So yeah, I highly recommend it and trying it out.
Much. I was pretty positively surprised about success, and everything went very smooth. But we have one question related to your presentation. And Carlos asks, what kind of gases were used?
It was just compressed CO2. So yes, just something, again, we could get at the stores nearby, something just that's usually used for cleaning electronics, just pressurized CO2.
Okay, and other questions about presentation technique, sounds, this kit may be used in schools? Really no questions. I don't see in chat any more questions as well. While you are thinking, I have just for information from our conference lead a message that since we damage their session as they speak, they are in main room, they are behind the schedule. And for the sake of unity, I just want to invite, in behalf of Rasa as well, you to the main room, maybe to last presenter or two of them for the this another session. And after that, most probably, at least some of you will head for the next sensory perception session, and still, whatever session you may choose, we all have to wait when we will be assigned to these breakout rooms for the next session, because it of course was a mistake, but Rasa said it was impossible to change something after they scheduled these breakout rooms. Therefore, I invite all of us to join main session, and then Rasa will tell us about these breakout rooms not to happen anymore, something like that. But we happily reached nearly the final of this session, but maybe some more questions to Vigintas. If not, then I invite you to leave our conquered breakout room and to return to the main session. Thank you all, and until next panels.
Thank you as well. Bye-bye.
Thanks so much.